We're going to go through how to decide which inference method to use for a variety of different examples. So on the right side of your screen, you see a list of all of the different confidence intervals and significance tests that are possible, but this data down here is a lot to think about every time you do a problem. So really what you should be looking at is the stuff that's up here. This is going to give you a much clearer example of what to look at every time you do one of these questions. So if you can focus on that and not all of the different possible examples, it's going to make it a lot easier for you as we go through this. So before each question, pause the video and make a decision about what kind of test you'd run. If you want to pick them out off of that list that I have on the right side, you can look at that. So before each test, again, pause and see how you would do. For the first test, because we're being asked to estimate a proportion, you have 85% of a sample, and we're trying to estimate the percent of all parents who use these baby bathtubs. Because we're estimating a percentage, it's a proportion, so right there we know that, and there's only one proportion that we're estimating, not more than one. There's not more than one sample. So this is a one sample Z interval, because it's a confidence interval, since we're estimating a value for a population proportion. And we're always inferencing about the population, so we're never going to be making an interval for a sample. All right, so go ahead and read letter B. So when we're making the decision here, we need to look at the data that's being collected. These adults are being asked to rate two different things. So they both rate a number on 1 to 5 for speeding drivers and noisy neighbors. So one person is giving two different ratings. Because we don't know the population standard deviation, and this is not a proportion, this is just a rating, we're going to have to use a t-test. And because the rater is giving two different ratings, that is the reason that it's going to be a paired test. So this is a paired. Now this is it's not a confidence interval because we're not asking for the mean difference in rating. We're being asked for, is one more than the other? So this is a paired t-test for a difference in the mean rating between, in this case, speeding drivers and noisy neighbors. If I could spell. So there you go for the second one. For part C, go ahead and pause. So here you want to look at your samples. So the first one is students who failed to graduate in 7 years. So that's one sample. And then another one is sample of students who entered at the same time and did graduate. So you're looking for differences between these two groups. So you're going to use these data to compare percents of students from rural backgrounds among dropouts and graduates. So because you are comparing percents, first of all, you know it's a proportions test. You are, it looks like, looking for differences between those because you want to know if someone from a rural background, if there's a difference between those with dropouts and graduates. So for that reason, we're looking at a difference in proportions, and there's no T or Z with, option with proportions. It's just the Z test. So this is a two sample Z interval because we're looking for percents. And we're trying to compare the percents and look for a difference in these percents. So this is a two sample Z interval for the difference in proportion, and in this case it's between types of dropouts and graduates from rural backgrounds. This should be for the difference or a difference. So for D, go ahead and pause. For this example, you have, as soon as you see that they are assigned to two different groups and it's a study, you pretty much are going to know it's a t-test, because there's no way really for us to know about population standard deviation in this case, especially if we're applying a treatment to one of these groups, which is someone's cheering them on versus them playing alone. So in this case, we're going to use a two-sample t-test to look for a difference. So it's not asking us what the score is, but what we want to know is, do the experienced computer game players earn higher scores? So you're asked to make a conclusion here. So that's why we're going to run a significance test, and why it's not a confidence interval about score. Although you could run a confidence interval, find the score, and look for the difference, and as long as 0 wasn't in the interval, you'd be able to make a conclusion. It would be more common to run a significance test in this case. So you would use a two-sample t-test for a difference in the mean score of computer game players with fans versus no fans, or however you want to word this. Again, if you ran a confidence interval and still were able to come to a conclusion, you could make the argument that that would be the appropriate test to run in this case. For 62, part A, pause. So as you read this question, again, think about the data that's being collected here. The female and male partners are being asked to compare two different relationships. They're collecting a data point from a relationship when they were age 15 or 16, and they were also giving a data point for the relationship that they're in now, and how much the attractiveness of their partner matters. So you're looking to see how much different men and women are in this particular case. So I just want to restate, because I may have said it in a confusing way. Each man and woman is giving a rating on this romantic relationship from when they were 15 or 16, and you want to know, is the difference in those ratings significant? So because of that, you're going to be running a significance test. Now, if you wanted to run the significance test and figure out how much more one did than the other, you could do that. Let's write that down. Now the significance test would be a two-sample significance test, and you're looking for a difference in the mean rating of partner attractiveness. Now in this case, again, you could also run a confidence interval, because specifically it says you want to find out how much men and women differ, not is there a difference. So upon reading this a little bit closer, how much men and women differ, if you want to know literally the number of how much they are different, then in that case you actually are going to need to use a confidence interval. So a two-sample confidence interval. Now it's going to be a t-interval because we don't know the population standard deviation for the mean rating of partner attractiveness. Again, you really want to pay attention to what's being asked, and this is a perfect example of where I went back and really reread that question to make sure that we got it right. So in that case, you've got a two-sample confidence interval for this difference. Okay, let's read letter B. So after you read letter B, again, you want to look at how many people are being sampled. In this case, you're only sampling Toyota owners. You're not comparing them against anybody else. So you've got a one sample test in this case. You're asking them, are they satisfied? You're getting a percent as an answer. So this is going to be a proportions example. That's what you're measuring. And that's basically it. You're just deciding, am I running a confidence interval or a significance test? So if we want to know, are more than 75% of them satisfied, that sounds like a hypothesis test, a significance test, right? Is it 75? Is it more than 75? So we're going to do one sample, in this case, Z test for a proportion of Toyota owners satisfied with their vehicles. Read part C. In this example, you are specifically looking for a difference. So you have our one set of students more likely to binge drink than the other set of students. So if you're asked to make a decision like this, rather than the last question, or sorry, a couple questions ago, where we were asked how much they differ. So if you're looking for how much they are different, you're looking at a confidence interval. If you're looking for is one more likely than the other, you're looking at a hypothesis test. So because we're surveying them and asking whether or not they have engaged in binge drinking, that, think of that as like a yes or no question. So we can use a test for proportions, right? If 50% of men say they have and 40% of women say they have, then you can compare those two proportions. So this is going to be a two-sample test, and it's going to be a Z test for proportions. Again, there's no T test for proportions. For the proportion of, male versus female college students who have engaged in binge drinking. And part D, you can pause. For part D, because we are looking at two different incentive plans, and you're looking for which of the two will most increase the use and by how much. So this really seems to me like a confidence interval right off the bat, because we're looking at an amount that we want to know how much did it increase. So if we want to know which one increases the most, you're going to be looking at comparing two different samples, subtracting them, and seeing which one's bigger or smaller. So in that case, you're going to be doing a two-sample interval, and you just have to decide, is it a Z or a T interval at this point. Now, because we don't know the population standard deviation, and it's unlikely that we'll know that, we're going to say it's a two-sample T interval for the difference in, now is that, a mean increase in the use of its credit card. So a two-sample T interval for the difference in mean increase of the use of the credit cards in this case.